In this example, we are given that a convex lens of focal length 20 cm and a concave lens of focal length 10 cm are placed 10 cm apart with the principal axis coinciding. Now it is saying a parallel beam of light of diameter 5 mm is incident on convex lens symmetrically. We are required to prove that the emerging beam will also be parallel, and we are required to find its diameter. If we draw the situation in this example, we are given that there is a convex lens having focal length, say it is f1, which is 20 cm, and at some distance from here we are having a concave lens. The distance between the two, it is also given to us as 10 cm. And this second lens, concave lens, which is a diverging lens, is having focal length also 10 cm. Now a parallel beam of light is allowed to incident on the convex lens symmetrically. It is given that its diameter is d, and here d is 5 mm. Now we know that when a parallel beam incident on a converging lens, it converges to its focus, which is located at a distance 20 cm from the lens. That means it is at a distance of 10 cm further away from the concave lens. This would be the focal point for the lens 1. So these all light rays will be focusing toward this point. And here we can see this f1 can also be treated as a focal point of the lens 2. This is the same point which we can regard as f2, because for diverging lens light rays which are coming from left side, the focal point which is used is located on the right side. And we know when light rays are directly going toward focus, and a diverging lens will become parallel to principal axis after refraction from the two surfaces. So here we can see that the parallel beam finally will emerge out from the lens system as a parallel beam only, which we are required to prove. And we are also required to find its diameter. Here you can see if this diameter is d1, we can see it is reduced because the rays are converging after the convex lens. So here if this distance we consider as AB, and this distance of beam we consider as CD, and this focal point is F or F1 or F2, then in the situation we can see if optical centers for the two lenses are O1 and O2, then here we can write by similarity of triangles. In this triangle here we can see that AB divided by O1 F1 must be equals to CD divided by O2 F1. Here this AB is the diameter of incident beam, which is D, divided by O1 F1. Here we are having this O1 F1 as 20 cm, which is equals to CD, which is the diameter of emerging beam, which is D1, divided by O2 F1 is 10 cm. This implies here we are getting the diameter of emerging beam is equals to D by 2, that will be 2.5 mm, as we are given with the initial diameter to be 5 mm. That is the answer to this problem.